In a recent video, I showed how to add a module, and we called that module YT_test, which is highlighted here. Now, we did not check in those changes, so I currently have a dirty tree, all this, and this. So let's make a branch and get that put away. Alright, now what I wanted to show was how to make this a threaded renderer. Now the easiest way to do that is to actually just steal from one of the existing modules, Plasma, which is relatively simple but also threaded. What we want is a prepare frame. So we're going to steal this. And we're going to replace Plasma with YT_test. Now we don't have a context yet, so we're going to just throw this away. And then just need this. And that should, I think that should be good enough, because the way that this is written currently, it's completely constrained to the fragment, and this fragmenter is going to just produce smaller fragments for this existing render fragment to do the right thing. And those will get rendered in parallel if there are multiple CPUs. So the real magic here is just implement a prepare frame, produce a fragmenter, and there are some generic ones here, like this slice per CPU times 16, that's going to horizontally divide the frame coming in. 16 times the number of CPUs there are. And that should be it. So let's make sure that that compiles. Just going to background that. Now, make sure it makes a white screen. It does. Now, how do we verify that that's actually threaded? An easy way to do that, let me just go back to there, is to run top and see how many threads there are running rototiller. And this is a bit polluted because I have another desktop session running. But we can see that there's a 1, 2, 3, 4, 5. There's a bunch of threads. They're using a bit of CPU. Now, this rendering is limited by the frame rate. There's another trick that we can use to get rid of that. And this is the mem video driver. That's going to go as fast as it can. So it's 4,800 FPS. And we can see, I'm on a 4-core laptop right now. You can see rototiller is driving 4 cores. So let's go back to here and back into our source here and just comment out this. That warning's fine, and we'll run this. So it's going 3,000 FPS, and only 1 core is busy. So we get a performance boost. Now this is a somewhat contrived example because all we're doing is filling the fragment with white. Once you start actually doing more complex rendering algorithms, the fact that they're occurring concurrently, I mean, it complicates things. But this is the gist of it. This is really all you have to do. The other thing to keep in mind is prepare frame runs serially and render fragment runs potentially in parallel. It runs concurrently. So if you have any upfront work that has to happen, you put it here. You just, any kind of like variables that need to be advanced per frame, maybe you need to do some math against the current ticks value, stuff like that. You would do it here so it occurs once. And then over here, and so on. I didn't want to make this video very long. Let's just let's check in these changes so we can get more of the Git workflow kind of represented. And I think I'm going to stop there. That's enough to maybe get some folks going. Until next time.